So before we begin here, I'm going to tell a story about Brandon. So more than 5 years ago, he convinced my team that we needed to buy a 3D sand printer, believe it or not. And so we went and to a very cold visit to the University of Northern Iowa. And I think we had the rare wintertime tornado warning on that visit, which was very, very interesting. So anyway, without further ado, please begin your presentation.
All right. Good morning, everyone. Thanks for joining us. Really appreciate the response of all the people that have signed up. That are with us. It looks like we have over 35 people in attendance this morning. As well as this will be recorded and sent out. For those that had other meetings and vacations, etc. So it's been this journey, like as Kirk mentioned, has been very long and very exciting. The people I've gotten to work with. Just briefly at the table. Working with, George Maska at Caterpillar, on one of the largest programs to date. It was one of our first. It was, having success and growing, the network of people and the companies that I've been able to work with on this journey has really been phenomenal. This morning, I'm joined by, Ricardo Toledo. I met Ricardo probably over, I don't know, probably been 7 or 8 years, Ricardo, since we've met. Down in Brazil, and it's just really been great working with you and everybody down in Brazil, all the foundries that have joined. So, so Brandon, I'm the additive manufacturing director at Hometown Products, and I'm blessed to work with a great team of people that have really taken this journey with us. Our team members, really diving in as a pattern shop, that's been around for over 60 years now. This technology has really been great. And Ricardo, I'm going to let you introduce yourself, what you've been doing. Let our guests and colleagues here, if they don't know you, get a chance to know you. So by all means, go ahead.
Okay. First of all, thank you, Brandon and Hampton family, for this great opportunity to talk with you guys and our audience. Thank you very much, and I'm honored to be part of this very interesting project you are leading. So thank you everybody to attend to this nice event, and hope to present very good and valuable information about additive manufacturing, 3D printing business, considering my experience here in Brazil and South America with the technology and the challenges we have had to introduce the technology and to have the adoption for the companies here. So hope you enjoy the presentation. So I have a background working on a foundry, about 25 years experience, mainly with consumables like binders, ceramic filters, coatings, sand, for shell molding process. So producing binders here in Brazil in partnership with companies from Italy, China, and 7 years ago, looking for some innovation in this market, try to bring something new. I found the additive manufacturing applied to the foundry business and say, wow, this is the good things I have ever had in the 20 years working in this business. So I made contact, first of all, with X1. I have the opportunity to work with this company for about 7 years until August last year, but still with good relationship, also talking with other OEMs, with other processes that could be applied to the foundry industry. And right now, I'm working also in a project to start a service center for 3D sand printing in Brazil. It's a huge challenge we have in front of us, and to move forward with that, and hope to have some good news in the near future about that. Thank you very much. So please enjoy the show.
All right, Ricardo, why don't you talk a little bit about the sectors, the business sectors, for those that aren't as familiar with the Brazilian foundry market. Why don't you talk a little bit about the slide here that you had sent over to me about the market?
Yeah, this is the how the sales for foundry industry are distributed. It's from 2018, but it's not changed so much in the past 2 years. So the biggest sector for the casting products is still the automotive, with almost 60% of the share. So after that, we have the other like infrastructure, the other things like steel industry, mining, infrastructure, the sugar industry, machinery, rail, but mainly the biggest one with almost 60% still the automotive industry. So that's why it makes sense the adoption of the additive manufacturing, because the automotive industry, have very huge demand for parts that becomes more and more complex. So that's why I think and I believe that additive manufacturing it's a brilliant tool for reaching this challenge that the automotive industry have for develop new products, focusing on reducing weight, reducing lead time for prototyping, and also thinking about production, and also thinking on environmental issues, so reducing emissions and scrap and waste.
Yep. Yeah, and we've seen, all of those, with additive manufacturing, here, in the U.S. and obviously around the world. So, talk a little bit about, the maturity, of additive manufacturing in Brazil, where you feel, it falls, and, what do you see, in the near future, given what you had just mentioned in your introduction, you can address that by using additive manufacturing.
Yes, I like very much this chat because this is we call it diffusion innovation chat. It's from maybe 60s. It's a very old chat, this one, but it's pretty interesting because we can see the maturity level for new products and innovations. So I think from my perspective and looking for Brazil scenario and South America, we're still a little bit in this early majority for adoption for the technology, because talking about the automotive as a good example, our industry here is not really developing new products. It also come from abroad, from the OEMs headquarters, almost to develop it, and then we just need to produce the casting parts for the automotive industry. We have almost all the OEMs in Brazil right now. Unfortunately, Ford is leaving after 100 years as part of the strategy, but we see that the main focus for the casting foundries here in Brazil is oriented to production, as we have just a few product developments by each OEMs that will not be enough to justify and to have a ROI for investing in a machine, in a big machine like a 3D sand printer. So based on that, the business model that works in Brazil should be services.
Okay.
So for service, we have a huge demand for attend all these foundries and OEMs that have presence in Brazil.
And that service you feel will probably be targeted towards prototypes at the beginning?
Almost for prototypes in the beginning. Yeah, sure. But also we have some kind of customers that need for production already.
Okay.
So, but almost for prototyping, because as they don't have enough volume itself for have their own machine for service, for sure, it will be very good for them. So working as additive manufacturing as a service business, this is the concept behind our idea.
Okay. And based on the chart that you sent over, it looks like, one of the biggest drivers is to get that reduced time to market. Is that correct?
Yeah.
What you're seeing?
Yes. This is a very good one. I received from Vogel Communications. It was a survey with more than 500 people from different industries and different level. So engineers, people from the production area. So more than 500 people responded to the survey. So reduced time to market is still one of the main reasons for the adoption for the technology, and optimization of product features, reducing weight, topology optimization, some changes on the design. So becomes also a second preference. So it's a multiple choices survey. And also you can see the acceleration of product production times and cost reduction. It's interesting because first of all, you think that cost reduction should be the most important one, but the reduced time to market is still the most important. And doing the same research here, talking with some founders and engineers here, I felt in the beginning that it's really quite similar, the results I'm receiving from the Brazilian engineers and companies here I'm talking about.
Yeah, that's really good. So it seems like you've done a great job of talking to foundries. What would you say, how many foundries, are in Brazil are using this technology? I know it sounds like you don't have a service center, but I know, ourselves, we've shipped to multiple foundries in Brazil. You being in Brazil and visiting and, inquiring these foundries, how many foundries would you say, or what percentage of foundries would you say have at least used digital manufacturing, 3D sand printing specifically?
Not too much, Brandon. Of course, there is a barrier for the costs. So to import this kind of service from abroad, from you, for example, in Hampton, there is a risk for damage. And also the cost, considering the freight, insurance, and also the import duties in taxes and other things. So to produce cores in Brazil in a traditional way is not too much expensive, even if you consider in the tooling. So that's why we are insisting in this idea to have the service center here in Brazil to supply those foundries with prototyping or even production for small series or single parts. So just a few of the big foundries that have a worldwide presence, like TP, Steel, Romy, and other ones like that.
Yep.
It's experimenting the technology.
And would you say most of that, the introduction of the 3D sand printing, has it come from the United States?
United States, Germany, and other service providers around the world, like Thailand, sometimes from China.
Okay.
But basically, they are trying to have the first contact with the technology, importing the services from abroad.
Okay, no, it's really good. As some people on the call know, Humptown, this is a photo of our current 3D sand printing facility. We started a couple years ago with just one printer, through a grant with the local Youngstown State University, American Makes. During 7 years ago, with Jerry Thiel and the team out at the University of Northern Iowa. So, it's really interesting, Ricardo, to hear that your story is very similar, to what we've seen, in the United States. Places start with one printer, and then based on some prototyping or some new product introduction, they will use 3D sand printing, and then next thing you know, we're moving right along into full-on production jobs. And it's really exciting to hear that that you've had the introduction through companies like ours, and from other around the world, China and Germany. So and that you're embracing that technology, and you're ready to take that next step. On the graph here, the time to market, as you mentioned, for new product, everything is going to have to start with the casting requirement, developing that 3D CAD model. If you decide to run simulation, modeling once you have the gating, but from there, you're going to skip a lot of these steps. I don't know. Do you have a feel for the foundry industry in Brazil? What the typical lead time is for manufacture of pattern and core box? Do all that. Do you have a rough lead time?
When you talk about the automotive, and for example, talking with complex parts like the water jackets, it's take more time.
Yeah.
3 to 5 months,
Yep.
depending on the complexity and everything else. But for the other kind of castings, for example, we have a huge market for agriculture machinery. So this one, less than a month or even a month and a half,
Yeah.
it's enough for them to have the patterns and tooling to starting some prototyping. So the main problem right now for these companies, they are working in full capacity production, and they have to stop sometimes the production to introduce a new prototyping for casting. So they have some disruption in the production, and this is a big issue for them. So it's time they spending to produce for developing new products. And that's why also we are thinking about to have prototype castings, not only the idea is to have the entire services from simulation, 3D printing, sometimes trying to help with the design for additive manufacturing. That's something very important for the adoption of the technology, to get the real benefit of the technology. So things like that we are trying to help companies here to looking at. Yeah.
Well, and if you can, reduce the steps, print, 3D print even just one core, of a package or multiple, that's what we really like to see is, design validation, because, maybe you want to adjust your gating, your shrink, rate if it's a very large part, and that's what we've seen a lot here in the U.S. We'll print, a complete mold package, we'll pour that casting, verify, the dimensions of the casting, and we can do multiple iterations, if needed. And then, after you've done that, which only takes a few weeks, then you can go to your hard cut tooling. That's a huge benefit, of this technology is, if you a lag time from getting tooling, and in worst case scenario, the tooling comes in, and if it's wrong, and then you have to send it back out and make all the adjustments.
Yeah.
So we see a huge opportunity, for almost, design validation, almost every casting, could be 3D printed for it, take dimensions, make sure everything does exactly what you expect, and then, go into cutting. So I think that, especially if you don't have any capacity at the foundry, you don't want to do, a lot of back and forth with tooling on and off machines. You want to be able to cast it and get your parts. Talking about, production jobs, this brings up a very interesting, point of view. You have a lot of highly complex production jobs in Brazil, and as you mentioned, you're in, basically full capacity. So, have you seen the opportunity for all the cores like I have on the screen here? This was 7 or 8 different cores that were blown and assembled, where we were able to just print one solid monolithic core and still use all the production equipment and molding lines at the foundry, but just place the core. You seen any applications similar to this in Brazil?
Yeah, sure. Yes, a lot of them. Yeah. It's as I told you before, to teach the customer also to explore the benefits of the technology. It's not just to read the process. You need to think about how you can design and develop your product, think in the which way you use to produce them. So through additive manufacturing, applying the concepts for designing for additive manufacturing, focusing on reducing weight and improving quality, topology optimization, generative design. So exploring this features of the technology, you can, reach and applying things like that to improve your quality and product life cycle, anything else. Yeah.
Right, and you actually can reduce assembly and glue and stacking, and in your core room, you can actually open up some capacity. And I understand, you have to start doing the 3D printing services to get that introduced, but then after it's introduced and it works, that's when you're going to start seeing more point of view printers actually being placed in the foundries. That's what we've seen.
Yes.
When you can take all this core make and all this assembly time on the bench with gauge and glue, and on the right you have a single sand. It increases the accuracy. Just so many benefits. But I agree. If you don't have the ability to do these tests and trials, at a cost or a price point that's reasonable, it's a huge barrier. Because you never have an opportunity to try this, in your factory.
Yeah, I think to build a cost model and during your process to understand the ROI for your AM project, it's important just that you consider all these steps and benefits from the technology, right?
Yep.
Good.
So how could we work together until you have your service center running and you have, sand printers available? We need to start thinking, how can we help the market by by consolidating shipments? If there's foundries that want to try 3D printing, can we consolidate all of those into a container and then ship container multiple foundries? That I think that was a really good opportunity for us to work together and to help getting this technology into the market.
Sure, I think this is a very, very good way. Try to consolidate shipments, so bring more customers together to explore your services in Hampton. I know you have good experience in quality. We received some cores, some customers here in Brazil received cores printed in Hampton with very, very smooth surface finishing, very good sand quality. This is another issue that we are developing in Brazil. Try to find out a very good sand to be used on the machine.
Right.
And I think this is fantastic. To try to consolidate multiple customers with different projects working together to print their own demand and ship together to optimize the shipment and the costs related to that.
Well, and you bring up,
it's a good alternative.
Yeah, and you bring up a good point. A lot of foundries around the world buy sand from the United States. Down in Mexico. I'm not sure about South America and Brazil, but if foundries are buying sand from the U.S. Anyway, we could do some of the value add, put the sand into the shape of the core, and ship them down ready to be used.
Yeah, it's a good point because the sand in Brazil, it's very cheaper. So comparing with the price of the sand in dollar in the United States or even in Europe, becomes pretty much expensive to import the sand. So the cost per core becomes, for prototyping maybe it could be in some cases okay.
Yeah, the production definitely gonna have to look at that. When 3D sand printing came out in the United States, the sand was a special screen. It was very expensive, but we worked as a community working with universities like, University
Mhm.
of Iowa, and with sand suppliers and resin suppliers. And, we do realize we have to keep driving those costs down because, the castings are very competitive, and, it's not a large margin industry. So we have to be sensitive to that. And I agree. I understand, that would be a hurdle in Brazil as well as the United
Yeah,
States.
sure.
Obviously, we can, the cost is one thing, we got to have the benefits, from market. And we talked about that, with your survey, that was a very big driver for your technology. Just a couple other pictures while we're finishing up talking here. Obviously, you don't have to use additive manufacturing. It's not all or nothing. You can use a hybrid approach, use
Mhm.
and I think, you'll see that, as you're developing out your market in Brazil, you don't have to have all or nothing. You can use just one 3D printed core if you have a design change,
Mhm.
sample it before changing tooling. So. But, Ricardo, as we're wrapping up here, what are some ways, that you can help, integrate this technology? How can our listeners reach out to you? Obviously, if they want to email us, we can put in contact. But what are some of the things that you can do, to help any of the OEMs or people that need to make castings in Brazil, because they're an OEM and there's a high import duty, and
Mhm.
working with foundries in Brazil. Maybe explain a little bit about how you can help, customers.
Sure. I know, as I told you in the beginning, on my introduction, I have more than 25 years experience working as a found supplier, mainly in this area, supplying sand, supplying binders, supplying ceramic filters, coatings. So working together with the people who produce the cores and molds for the casting. So I have good knowledge. Comes from my father that have more than 4 years working. Now he's retired, but also working in this market for many years. You had the opportunity to meet with him
I was going to say,
7 years,
I bet he's
7 years ago.
working, even though he's retired. I'm sure he's still working a little bit, helping you and helping other foundry members.
Yeah, he's living in the beach right now.
Good for him.
Yeah, good for him. So that's why my experience came from. So from the experience of my father working with him and 25 years working in this market. So I know almost all the foundries here. And of course, if you have customers that need to produce some parts in Brazil, I can help them to find the best foundry for different kind of alloys and process. Also, with some experience using 3D printed cores and molds. So,
And obviously,
yeah, that's
with that, we can work together and become a total solution.
yeah.
Working with you and producing the cores and molds, and then obviously once you get up and running in Brazil,
Yes.
we'll have that to offer. So that's
Yeah.
well, once again, thank you so much, Ricardo. We're going to wrap up here around 15, and we're going to go back out and we're going to do some Q&A. Just a little plug, we're going to be doing a series, on this, and up next we're going to talk with the Indian foundry market, and
Great.
and I are going to have a discussion. Ricardo, hopefully you can join us and listen in. Very exciting to see what's going on globally,
Sure.
around the world with this technology. I think the more we learn together and push this further, I really feel that it's going to, get manufacturing at the point of need. There's so many castings, to be made in the United States, but that same casting, for the same OEM might need to be made, around the world, and 3D printing is really going to help, push that. So just really appreciate everybody, joining in on this. We're going to go back out now. I'm going to stop sharing my screen. And I think Kirk is going to probably kick us back out to the tables. First, before we do that, I want to see if we have any Q&A.
Yeah, there's two questions, Brandon, that got some upvotes I sent you privately.
All right, I'm looking at those now. From Kurt. Okay. All right. So this is from Tom Pruka. Tom, thanks for being here. Since a good portion of the Brazilian automotive castings are focused on powertrain, like crankshafts, blocks, et cetera, how does the shift away from the ICE affect the foundries? So obviously, we're seeing a lot of movement here in the U.S. on electrified vehicles. So as we get away from the internal combustion engine, how do you think that's going to affect the foundries? Obviously, you said they're running at full capacity right now. Can you talk a little bit about that, Ricardo?
Yes. Past week, I have a good discussion talking about this. The electrification. This mindset change for electrification, electrical vehicles, and also this mobility. So a week ago, Ford made an announcement here in Brazil that's leaving the automotive production in Brazil. This is part of the mobility strategy. And after that, 100 years producing cars in Brazil, now they're planning to leave. It's bad news, but we understand that's part of the strategy of the company. And we are discussing about the impacts because others should have same moves. I think we will never see the automotive production in the same levels that we saw 10 years, 5 years ago. So there's a completely shifting to this new way of mobility, and also considering the electrical vehicles that it will need less castings and also different alloys like aluminum and magnesium. So we are in a good discussion here in Brazil because all the foundries are pretty much, worried about, and they need to move fast. So I like the ACE ex-CEO from GE, Mr. Jack Welch, that say you need to change before you need. So that's why we are talking about that here a lot in Brazil. Yeah.
Very good. Yeah, it's definitely gonna. There's change, but we just have to be ready for that. And like you said, maybe the technology, but you also use the experience that you have in one alloy, and and change maybe different alloys or different types of castings. A couple other questions here, real quick. Looks like Jose asked, what type of sand can be used for the 3D printer? Ceramic, carbo, silica, other alternatives? Absolutely, Jose. We definitely right now are printing with a round grain silica. That's our workhorse. Do some printing ceramic. We can print either the carbo. We've also found that the Itochu Cerabeads work really, really well, very consistent. So we use that. We also have some customers that want to use, black iron oxide, for steel casting regularly, as well as like a zircon blend. Typically, with the price of zircon and the density, we don't like to go 100%, but we found some really good blends, even up to 50 silica and zircon that work well for water jackets and things like that. Other quick ones. What are the printing time, for example, on a 4-cylinder engine block? So the printers, as you saw in that one photo, you have a build envelope. So you would not just print one cylinder block. You'd probably put, on a 4-cylinder engine block that size, I would assume you could probably get 8 to 10 packages, and that would print in about 18 hours. So, but as you saw, you put 4, 5, 8, 10 printers in. We're not talking full scale F-150. EcoBoost production, but there's a lot of high performance, a lot of applications that we've quoted very high. We're doing alpha runs. We've done all the way up to a 6,000 piece gamma run for an automotive company where they had just one core out of the package. It's very complex. So we do understand that you might not want to do the whole package in production, but maybe the water jackets or maybe the ports, maybe you consolidate those and maybe you print a couple hundred sets of water jacket and ports a day.
Right, I think that's probably it.
Yeah, we're running out of time here. Thanks so much, everybody, for joining. For myself, looking forward to talking to Ricardo more on projects, with hopefully some of you that have attended, and we're to help any way we can. So thank you so much. All right. Yeah. Thanks everyone for joining, making the time. We tried to pick a time that would, help some of our colleagues here in the U.S. be able to join early. And, we appreciate everybody over in India, taking some time out of your evening to join us. Our two panelists here that we're going to have some great discussion about additive manufacturing, as well as, all the participants, everybody that's joining to learn. So, it's been quite an adventure, stepping out, as a company that's been in business for over 60 years, going from conventional manufacturing to, entering into this 3D space. What we're finding is that the community, although we have a very global, reach, it's a very small community, so joining with people, around the globe, like on our first, perspective on 3D sand printing, meeting with Ricardo Toledo and people in Brazil. We found, through networking and, through some really good opportunities, to meet with Aditya and Sam today, to hear a little bit about what is taking place in India, what Humtown can do is, to help build a bridge, for our colleagues here that need to, make castings, overseas. We develop sometimes castings here in the United States, but then, that casting design is very robust, and, maybe we need to take that, overseas, to, point of need manufacturing, in other countries. So we're going to have, some discussion this morning, about, from Aditya on, the Indian 3D printing network. I was on a webinar with him, not so long ago, and it was great, to talk and have, discussion points about what's taking place, in the United States as well as in India. And then Sam is going to give us a, really nice look at what some foundries are doing in India, utilizing, conventional, casting, using some additive manufacturing, some subtractive manufacturing, as well as direct metal printing. So have a really good opportunity today to hear about what's going on globally, and really appreciate Sam and Aditya for joining us today. I'm going to try to launch and share my screen here so that we can start with the presentation. All right, everybody should see the welcome screen, and with that, we're going to jump right into a little bit of background about Indian Printing Network, and then Aditya, we'll have you take it away.
Thanks, Brandon, for the introduction, and it's great to be here today with the two of the experts from the foundry industry, Brandon from the US and Mr. Krishna Samraj from Magna Electro in India. And it's really great to present our perspective as well as the Indian 3D printing network. So spend what we do. Co-founding neutral knowledge sharing and business networking platform for India. Our main goals are to really spread awareness about 3D printing and really catalyze the industry in those areas. So that's our role, and we are technology and agnostic as such. So we are trying to address the whole 3D printing ecosystem. Of course, today we are more talking about the foundry and casting applications where sand, binder jetting, and now maybe direct metal printing becomes plays a role. So to start off, can I request Brandon to move to the next slide? Yeah, so this is something we did in 2019 to kind of understand where the Indian AM industry was, because there was a lot of there was not a lot of clarity in terms of where the Indian 3D printing industry was. So this is just a baseline in terms of we're trying to understand who are the international brands present, what are the homegrown AM brands and service providers doing. So this is something which we did in 2019. We mapped the market. We created the India AM report, where the market value of the Indian AM industry, we estimate to be around $0.6 billion, which is about Indian rupees 4,500 crores. This is again focused more on specifically on 3D printing. So this gives you an idea in terms of what the size is, where what are the brands already present in India. So you see all the leading service provider OEMs and present in India already. So metal 3D printing has been growing steadily for the past 5 years, primarily focused on laser bed, powder bed fusion. Of course, the first sand printer came back in 2000. It was not the current binder jetting technology, but more of the laser sintering of sand, which came back in 2000, where one of the automotive OEMs used it for their casting and foundry applications. And what's happening in India is various applications. So if you're looking at automotive, tooling, dies and molds, jewelry, precision engineering, energy, there has been use cases where 3D printing is used. Obviously, maybe in the initial stages where it's more prototyping for some of the industries. That, for example, the Indian automotive industry uses 3D printing for prototyping very extensively for all the polymer applications. So they're well versed with the technology. Aerospace in the last 2-3 years has been growing pretty fast. There have been now parts which are flying as part of the Indian Air Force and Defense. They have been authorized to fly printed parts printed in India. So there's a lot of expertise now building on the metal AM side. Medical, of course, is something which is also growing. Maybe not that relevant to today's discussion, but medical 3D printing has been growing steadily as well in India with a lot of titanium implants and pre-surgical models, a lot of work on that side. So this gives you a broad idea in terms of the whole market scenario. With this, I'd like to move on to the next slide, where I'm talking more about the metal AM installed base right now, because that's something interesting in the aerospace, tooling, engineering, automotive, medical, and dental segments. Up to maybe around March 2019, we had about 82 systems across. Most of this is powder bed laser sintering technology. So we have again pretty much most of the brands represented in India across the board, and a lot of work happening in the aerospace tooling side for conformal cooling. Automotive is still is more in the infancy stage, and medical, again, as I mentioned, implants. A lot of dental implants are being printed, exported to Middle East and other countries. So that's an interesting model which has evolved as well. So why I wanted to mention this is with this structure, there's a lot of skill already being developed, to use a 3D printer, design for a 3D printer, which is very important when we come to something like a sand binder jetting, creating a mold, understanding, the orientation, the various aspects of to ensure that the mold can function as it needs to, and ensuring the quality of the part as well. So that's a brief on the metal side. If we could move to the next slide. This is which gives you an application split in India where AM is being used today. So obviously jewelry manufacturing is something which is big in India. So jewelry has been adopted pretty fast. So I think based on our recent estimates, about 80% of the jewelry manufactured in India today, 3D printing plays some role across India. So that's an interesting fact. What I'm trying to say here is that there has been adoption in very conservative areas like jewelry, which is more labor intensive. So jewelry has adopted 3D printing as well. Automotive transport, as I mentioned, is the leading adopter across polymer and metal, followed by tooling and engineering, jewelry, healthcare, dental, consumer products, electronics, education research is about 8%, and followed by government, defense, and aerospace, which is 6%, and others. So this gives you a breakup in terms of where is 3D printing used today across the Indian market. Moving on, we're just working on understanding the adoption of 3D printing in the foundry and casting application. So it's still not mature as an industry, but yeah, we already have about 10+ systems across India from most of the service providers here in India. X1, Voxeljet. EOS, of course, is a solitary machine, which is the older sandwinder, sand laser sintering technology, which was the one installed in 2000. 60 to 70% systems today are for captive use with OEMs, which are primarily used for their own use for various applications. Material and the binder quality is at par with global standards because most of it is imported, which is similar material which is used in Europe or the US. So the quality of the molds can be consistent with what is required from global standards. Foundries are opening up to adopting new technology. Of course, COVID has played a big role in changing mindsets because there's a lot of need for local supply chains, to future-proof our industry. So foundries are adopting, opening up to new technology. A few of the foundries are also taking up sandbinder jetting. Of course, India again has the necessary foundry casting metallurgy expertise available here. So it's all about understanding the business case, providing the right direction, and connecting the right people to make this happen. So I feel India has a big potential here to take advantage of this technology and see, look at advancing our manufacturing capabilities. And again, large engineering and engineering design workforce is available as well, so which can be tweaked or can be utilized to our advantage for the foundry and casting applications in AM. So with that, I'd like to conclude for today's session. I'd like the experts from Magna and Hometown to really take it ahead. But just before that, I'd like to sum up about us. So as I mentioned, Indian 3D Printing Network, we are a neutral knowledge sharing platform acting as a one-point contact for the additive manufacturing industry in India, engaging with the AM community on a constant basis. Part of our services, we started with a trade show back in 2015, which is today India's largest trade show on additive manufacturing. It's called AM Tech, which has been there for about 5 years. And we have had participation from the major brands trying to build a networking platform. We have own a publishing and media platform called AM Chronicle, where we're trying to again build awareness, spread the knowledge to the industry. As you've seen from this slide, we are working on our market research and intelligence to ensure that the right information is available to the industry to take decisions. And Additive Academy is something was born out of the pandemic, which we really developed to see if we can be the bridge between academia and the industry to really create skilling opportunities for everyone. So in a nutshell, that's what we do. And with this, I'd like to hand over to Mr. Krishna Samraj, who's been one of the foundries who's adopted 3D printing very early in the day and has the expertise right from design to implementation. So with that, I'd like to hand over to you, Mr. Krishna Samraj.
Thank you, Aditya. Good evening, everyone. Namaste. I'd like to, it is indeed a privilege and pleasure to be participating in this global perspective on sand 3D printing. And I would also like to thank Brandon of Hometown for organizing this as a good global collaborative effort. I would like to just give the audience a brief on our company, Magna Digitech. How it was started and how we got into the 3D printing business and some of the activities we are doing. Basically, Magna Digitech was founded in the year 2006, and we have 15 plus years of successful engineering services for the foundry industry. We specialized in troubleshooting, simulation, casting design, fab to cast, reverse engineering, everything based around the foundry, because we also have a foundry, Magna Electrocasting, which is 25 years old, and that is how we got started. So over the years, we said we were delivering virtual solutions and products to our customers. Now let us give them a physical solution in terms of prototyping. We have about 100 foundries in India and globally who use our engineering services for the foundry. The next slide, please, Brandon. The casting simulation services, we basically use the MagmaSoft, and I would dare to say we are among the top users globally of MagmaSoft, having done more than around 2,000 simulations to date, both for ourselves, for our foundry, as well as our customers, which are other foundries. I'm sure everybody knows here about the advantages and the pros of casting simulation services. The next slide, please, Brandon. Can we go to the next slide, please? Yeah. The prototyping, what we call the prototype express, where the customer needs quick and economically manufactured complex prototypes. The picture you see is of a 6-cylinder head, diesel engine head, which we manufactured right from the solid model to the end product within a matter of 4 weeks. Most of the time was spent on planning and designing. We printed the sand molds and cores, assembled it, and supplied it to the customer, whose collaboration was a Japanese company, and they really appreciated it, and they did not know that India could do it, do this type of development works in such a short time. The next slide, please. The second area where we play and we help with our customers is what we call complexity simplified. That is where a typical application would be in a hydraulic manifold, etc., where complex profile cores are required, and it has to, these are very delicate cores, and they have to be placed without any breakage. Of course, there are many foundries around the world who specialize in this, in hydraulic components, and their expertise. You know, I got 25 years expertise in manufacturing hydraulics. You are a new foundry, you cannot make it. Here, 3D printing broke that belief, because with the 3D printing capability, a foundry which was really not into hydraulic products was able to get into hydraulics. So the history or the large experience of 25 years, etc., was neutralized by this technology. That is of course, we should respect experience and technology, but it allows even other people to come in and break this technology. We can leverage. Next slide, please. These are some of the products which we have printed via binder jet. Our machine is 1.5 meters by 1 meter by 750 mm. Some sample things you're seeing for the 6-cylinder printed turbochargers, impellers, and hydraulic components. The next slide, please. In addition to additive manufacturing, we at Magna, we also do subtractive manufacturing. In other words, we give a customer a sort of a hybrid solution depending on the situation, depending on the products. If the customer wants, it's a very big casting, and customer wants only 1 or 2 pieces, we go via the Furon mold block and we mill the mold. That is the most cost-effective way, and the cores are done through 3D printing. Another hybrid approach would be the cores will be 3D printed and the molds are manufactured in our foundry, either in green sand or Furon. If a customer wants, let's say, 25-30 pieces at a time, that will be the most applicable. So we have a variety of options to choose from full-scale 3D printing to additive and subtractive manufacturing for low volume pieces, and if it is multiple pieces, 30-40 pieces, or like beta testing in the field, we do a conventional manufacturing and integrate it with 3D printing. The next slide, please. From these aspects, we have to date, we've started our journey on sand 3D printing in November 2017. And in the last 2 years, we have developed around 200 to 220 products, different products for the Indian customers as well as global customers. We have some customers even in the US for whom we do rapid prototyping. So from there, we said, okay, what is the next step for us? Okay, we have sort of established ourselves. Of course, there's still a lot for us to learn in sand 3D printing. We were looking at what is the next step to go see. From a foundry background, we always talk in terms of pounds or kilos or tons. So we said, okay, let us look at things a little bit differently and go look at direct metal printing. We have chosen to partner with Desktop Metal in the direct printing business, and ours is the first installation in India for direct metal printing. And we are still learning the ropes. We are still learning the ropes. The 3D sand printing and castings was very easy because we had 25 years of experience. People knew us, we knew what a casting was, we knew what the issues were, and our design services, engineering services, really accelerated our business case there. Here, we've got this machine installed. Again, it got hit by the COVID issues, and this machine was installed from November, and we are slowly feeling our way, and we've got a couple of applications for the desktop metal printer. Here are some of the parts, sample parts, which we have printed on this. The big difference here is the physical size, the physical weight of the parts, and the challenge to have customers designed for additive manufacturing. The engineering at our customer side, the challenge is for them to design these parts for this. And for example, we should see that helical gear and pinion in our binder jetting desktop metal machine, they are not solid products. You know, they have a honeycomb structure inside. Our customers are used to solid products. They're saying, hey, this will not work. Why is this weight so much? When I say customers, this is customers in the traditional earth-based industry, not the aviation guys. The traditional earth-based industry where weight doesn't matter much. So that is some challenges which we are looking at. Over time we will get over that challenges. The next slide, please. So the basic in-house technologies we have are the Furon 3D printing machines. I'd also like to add here, we also provide completely machined, ready to assemble products, as well as validation. We have a Romer 6-axis absolute arm scanner, a 5-axis machine, and other bigger machines which we have in-house in our in-house machine shop. The next slide, please. These are our facilities. One is the machine shop and direct metal printing, what you see on the right-hand side, and on the left-hand side is our sand printing plant. They are in the city of Coimbatore. With this, I'd like to thank everyone for their patient hearing, and I turn it over to Brandon to take it forward from here. Thank you, sir.
Sam, thank you. And Aditya, both of you, I think you've really kind of honed in on some of the future, of additive manufacturing. It's interesting. in our last discussion in Brazil, they're still working to get, consolidated effort to get a 3D printer, sand printer in country, to use for multiple foundries. But here, seeing what you've built and the technology that you're growing upon, it's a step. You start with one technology, you take a step, you use another technology, and we always say in additive manufacturing, you have a toolbox, and it's really neat to see all the tools that you guys have in your toolbox to get the end customer what they need. So congratulations on things that you're doing. Thank you for sharing that with some of our colleagues here in the U.S. so that they can see some of the steps that that maybe they can take. But this technology is really enabling what I've found in our role at Humtown. We 3D print parts for foundries. We don't cast parts, but we help a lot of customers put 3D printing pieces of equipment in their facilities. We do consulting, we go in, we help them understand the technology, where to use it. And I can tell you, every single time that I teach somebody how to use the technology, almost every time they come back and they're some of our biggest and best customers in the following years. And that's because I really truly feel that there is so much opportunity in the market, not just locally here in the United States, but globally, that by partnering and working together, I really feel that we're going to go so much further together. So like I said, I can't thank you both enough for that. I was just wondering, Sam, one question that kind of came to mind. You have a list of questions. You covered most of them, both of you in your presentations, and I really appreciate that. How many machines are in India, compared to other countries. I think having 10 plus sand printers is really amazing. But are you seeing the opportunity to 3D print direct metal parts to get into your customers' hands quickly, even though they don't have the metallurgical requirements, they don't have any certifications? But is that helpful to get a 3D printed metal part into your customer's hand quickly and then follow up using like 3D sand printing or mold milling hybrid? Sam, is that something that you've seen?
Brandon, we haven't seen much of that because the direct metal printing, whether it is laser based or binder jetting, whatever, so far it has been only for smaller sized components and what I would call exotic metal. The aerospace type, the light metal applications.
Mm-hmm.
So is there a demand to immediately print and give direct metal and then convert it into sand? I'm afraid not, because that is a different deal in terms of the scope, in terms of size, in terms of cost, in terms of reproducibility. It is a different.
Right.
If a customer wants something based out of casting, we can, within a matter of, depending on the queuing, within a matter of a couple of weeks, and how mature the design is. See, most of the time what we face is the designs are not mature.
I think that's a global issue. That's not unique to one part of the globe. Engineering has to hold on to a design as long as possible. And we've enabled that with this technology. So I had to laugh because we face the same issues. So that's interesting. So no, thank you for answering that, because that's always a question. For anybody using additive manufacturing. I heard the other day somebody said, "Oh, in 5 years, 3D metal printing, direct metal printing is going to replace foundries." And I kind of chuckled to myself and said, if you can find somebody that can 3D print a brake rotor or an engine block or a cylinder head, for less than I don't know what I threw out there, $5,000 or $10,000. I said, I show them to me, because we're talking huge castings that weigh hundreds of pounds, and I said I don't see that going away in the next 50 years. But I do, salute you in embracing direct metal printing, whether it's using a desktop metals or, as Aditya said, some, laser bed, there are applications for that technology. And in my opinion, I don't think that there's anybody better suited to get into that space than a foundry. You understand metal, you understand metallurgy, you understand, properties, heat treat, sintering, those types of things really fall into the hands of foundries, in conventional processes. So, I don't know, Aditya, if you want to chime in, you're on mute right now, but if you want to chime in on that, and then Sam, if you want to add anything to that, but from my perspective, I think that foundries are the perfect to take that leap into direct metal printing, not to replace castings, but to open up your product offering. What do you think about that?
Yeah, I agree. I agree about what Mr. Samrat says at what level we are, and of course, the 3D printing is one, as you mentioned, it's one of the tools in our toolkit, right? So it's not going to be the toolkit. It could in some of the areas, but if you look at rotating parts, there is still hesitancy to go for AM in terms of qualification and certification at various levels. And of course, as you mentioned, the kind of large parts which you're looking at casting is still, as you said, I think 50 years is something which is take these things to go. It's also important to see if the part is complex enough to really use AM. So I agree with both of you, and on that point, that metal printing is being used for smaller components. Of course, if you look at other areas like medical and stuff, it's directly used for implants, but then that's a different ball game altogether. But in the core manufacturing, yeah, it's more on the conformal cooling side, or parts which are complex in design are still being made. So it's still a long way to go for that kind of technology to come in here.
Yeah. And Sam, what do you feel about foundries being, in my opinion, a humble opinion, that foundries are the perfect place to use direct metal printing? What translates from your experience over to direct metal printing?
I think more than technologies, we foundry people need to have a completely new mindset, which is the most difficult thing. From tons and pounds and kgs, we have to move to grams and ounces. From a couple of dollars a castings, we have to move to $1,000 a casting. Most of us foundrymen, even when we started, we were afraid to even go and talk to the customer. How can somebody give $1,000 for such a small product?
Right.
So a big mindset change has to come. And foundries, we are used to dealing in mass production, mass volumes. This is a different mindset. It's not that it cannot be done, but it has to be separate. That is why even in our case, we didn't put it under Magna Electrocastings, which is a foundry. We spun off a small company like a startup, and have the average age here will be about 30 in this company. In my foundry, the average age will be about 50.
Yeah. Very
good. Different.
It's a good.
In the foundry, we talk about months. Here, we talk about days.
Yeah.
Well, not yet hours, but it may come to hours.
Yeah. No, I mean, I think that's a great perspective. You know what I mean? There has to be a fun shift in our thinking, before we can just jump in and say we're going to use our expertise in metal to become, a 3D printing expert. That's very good. Yeah. Guys, I mean, we could talk for the rest of the night, and I don't want to keep you up all night, but we do have quite a few questions over here in our Q&A. So I'm going to get to some of them. Some of them have been upvoted. The number one question is it possible to receive the PDFs so that people can internalize this? And I'm sure you guys are okay with that. We'll get that presented. This recording is also going to go out, so anybody. But we will provide those in a PDF format, that we can easily email and disseminate against the participants, as long as you guys are okay with that.
Sure, no problem.
And I'll
That's fine.
actually, Sam, you had a few more supporting slides. I'll actually package your internal complete package with that.
Okay.
Okay.
Great.
And then the next question was, is there a leading 3D printing OEM in terms of innovation, efficiency, and adoption to the Indian marketplace? So, both of you, Sam, you've made some commercial decisions, obviously, on the brand you've went with. So we'll get your perspective first, and then what have you seen more nationally? So we'll start with Sam on that question.
Can you repeat that question once again, please, Brandon?
Yeah. Yep. Is there a leading 3D printing OEM? So, out of all the printers that you evaluated, is there one that's leading in the terms of innovation, efficiency, and adoption into the Indian marketplace? So that could either be a global one or an Indian manufacturer that you've found.
Okay. In India, as around the globe, it is the German twins who are the leaders for sand printing.
Okay.
The German twins are the leaders in the sand printing technology. Of course, we chose to go with an alternate machine, an alternate supplier for various other reasons, including affordability.
Okay.
But if you basically see, that the sand printing technology is a technology of integration.
Right.
None of the companies around the globe, sand printing equipment suppliers around the globe, manufacture everything. They integrate products. You take right from the printhead or the controller, the printed firing board. Most of it, the computer controls, the pumps, everything is available in the market. That is how good are they at integrating it, and the software presentation. Plus, of course, there's a lot of minute technology in terms of process controls and the droplets. You're looking at so many thousands of drops per square centimeter or square inch. How do we control it? The raw materials in India, if you look at the raw materials, it is the same raw materials. We can't take a chance with the sand, because in India, sand is treated as a mineral, not as a product. Sand is sand. We don't treat it as a product. So what do you mean a specification for a sand? There's nothing like that in India. I'll give you sand. I'll dig it straight out of the lake and give it to you. You do whatever you want.
Gotcha.
So none of us 3D printing companies in India use domestic sand. It is all imported from Europe.
Right.
Same way with the binders and resins.
Okay. And then Aditya, on your perspective, more nationally, maybe, what are you seeing for the leading OEM in terms of innovation, efficiency, and adoption?
Yeah, I think, the sand printing ecosystem is still quite small to really have a difference at a local and a national level. And I would agree with Mr. Samraj that there is the X1 and Voxeljet are the OEMs which are leading in terms of innovation, efficiency, and adoption. And also, as mentioned, it's all about the integration of how the inkjet technology works with the software and the entire ecosystem. So I feel in sand, it's really I won't see there is a difference between the national and the local implementation of sand 3D printing, at least.
There are no Indian manufacturers or OEMs of 3D sand printers. Is that correct?
Yes, there have been attempts, but there are no
commercially available
at the moment. There are
yep.
no commercially available systems.
Okay, great.
For sand.
No, thank you, gentlemen, both for your input on that. And we also agree. As a company, we have 5 3D sand printers in our facility, and it's very important. All the things that Sam said. You have to make sure that those printers, the integration, piece of equipment is great, and a company can come in and train you on, startup to start down that piece of equipment. But what we find and the value, that we provide our clients is the light switch to light switch, operations, setup. When you're setting up a cell, you may have X amount of dollars for the printer itself, but you have to really look into, the whole manufacturing process. So that's one. There is a question here about the process flow of 3D stamp printing. Unfortunately, we're not going to have time, but you're going to have all the contact information, for myself and Aditya. We can definitely go through, and we have supporting slides on the process flow of stamp, that we can cover. One last question. We got to wrap up here and start, go out and do a little bit of networking. But how have the universities been involved in AM and helped facilitate its growth in India? And that's a great question. And the reason that personally resonates with Hometown is because due to local universities like Youngstown State University, and then through America Makes, which is very similar to the organization, Aditya, that you run, they networked us, and we basically got our start in 3D sand printing between Youngstown State University as well as University of Northern Iowa. So without those universities, I don't feel that we would be where we are today. So I think that's a great question to end on. So take whoever wants to table that question, but how have the universities been involved in help facilitate the growth of AM in India?
Yeah, I'll take that at a overall level, because it's the sand printing industry itself is too small to talk only about that. But what we've seen is, if you compare it to the US, I guess we are, in terms of the research institutes and the industry working together, maybe we are about 10 years behind in terms of what needs to be done. But that being said, there are AM labs across all the institutes. So if you look at the IITs, which are the leading technical institutes in India, there is research going on materials. There is work going on processes. Recently there has been work across. Recently there was a part for the aerospace for the Indian Air Force, which was qualified locally, where an institute was involved. The Indian Institute of Science in Bangalore is doing a lot of work. They've developed their own technology for E-beam. They're working on that technology. So there is work happening across, but what's happening is now, this year, there is a central policy for additive manufacturing which is coming into place, which was not there for everyone to work in unison towards one goal. So I feel in the next couple of years, everything will kind of integrate and work towards a goal to grow the technology. So there is the Ministry of IT and Electronics, which is coming out with a policy along with creating a national center for additive manufacturing here in India. So I think this will now, in the next couple of years, kind of everything will synergize, and industry will grow pretty fast from here. From talking to everyone, I think there is now the large industries are now investing, and I'm sure they will invest in research projects as well, which will kind of then result in further adoption. So that would be my take on it at this moment.
Great. No, thank you. And then Sam, what do you see? I know our small company, 50, 60 employees, we reach out to local universities and trade schools. We are the customer of these universities to hire, engineers and technicians. So do you see, from a business standpoint, are you seeing, that you have access to good candidates, or are you growing them in-house? I guess would be kind of the perspective I would want to know from a small to medium-sized business.
See, India reputedly is the second nation after China to graduate engineers. The number of, in terms of numbers. However, there is a kind of dichotomy. Even though we produce the maximum number of engineers in all fields, mechanical, electrical, electronics, software, whatever, the bulk, the best, and the cream, they go to IT industry.
Gotcha.
Okay, where IT industry takes them, even if you're a mechanical engineering graduate, they train you for a year and make you into an IT wizard. So in terms of the challenge for us in general in the manufacturing industry, and more so for smaller companies like us, is attracting the good talent. So we are left to dealing with what we can get.
Okay, that's fair.
Which may not be the best. Whatever we get, we have to deal with them, train them in our own way, and keep them. That is the thing as far as talent goes. But on the other hand, all of our universities, money is not the problem. They have all kinds of equipment. For example, in my city, in Coimbatore, I think we were the second one with the EOS sand printers, the sintering technology, almost 10 years ago.
Wow.
I think what Aditya said, that may be our machine in Coimbatore. And it was put together by an industry association, not an individual company, an industry association. But spending money is the easiest part of a business.
Yep. Keeping it
what
going.
What do you do with that later is the challenge.
Yep. Well, that's
funds are not an issue. Funds are not an issue for our educational institutions.
Okay.
Yeah.
And keeping that talent in the foundry industry to be, part of the problem is trying to entice them to not go to the IT and other fields, but to keep them in the foundry industry can be a challenge.
Yes.
Is that fair?
Yes.
Okay. No, we see the same thing. You know what I mean? A lot of engineers want to go and develop product or and be in other industries, aerospace, and even though the aerospace industry needs casting, sometimes we do have a hard time acquiring that talent as well. But gentlemen, unbelievable. I have 20 other questions here, so luckily for our participant, everybody that came to join, they're going to be able to have all of our contact information. This will be recorded and sent out. I would be prepared to field a lot of questions in the next couple of weeks because this was a great turnout. I think we should definitely do a follow-on to this because I didn't allot enough time for any of us. So maybe I'll get up an extra hour earlier instead of cutting into your evening next time. But
no, perfectly fine.
Yep. So thank you, gentlemen. We are going to be back out to the networking tables. So you'll all be at your respective table. I'll be at mine. Thank you. Once again to everybody that joined us this morning. We ran over a few minutes. Thank you for your patience, your time, all the questions. And I'm sorry we didn't leave enough time to get to all of them. But this is a great session. And look forward to talking to everyone soon. And stay safe, stay healthy, and never stop innovating.
Yep.
Thank you.
Great. Thanks, Brandon, again for great being part of this.
Absolutely.
Hey, good morning, everyone. Good morning, Brandon.
Morning, Kurt.
Hey, welcome everyone to the third Perspectives on Global 3D Sand Printing, featuring a couple of interesting folks here from the casting industry in North America. I'm Kirk Rogers from the Barnes Global Advisors. I'm an advisor and our technical excellence leader. I'll be hanging out at the TBGA table. If you have any problems, come find me there or ping me in the chat and we'll help get you squared away. With that, I'll say, Brandon, take it away.
All right. Thanks, Kurt. Good to be back. Hard to believe another month has gone by.
No kidding.
Patty's Day. Happy St. Patrick's Day to everyone. Thanks for spending some time with us. I'm going to have Rich and Jerry join me here. We're going to get their mic and their cameras on, and we're going to start into the presentation. As a kind of leading into this is kind of where it all started. Myself and we went to the America Makes in Youngstown, Ohio, and said, we really are interested in this 3D printing technology about 7 years ago. And, we said we wanted to learn more. We wanted to understand it. We saw a value, but we didn't really know how to access it. There was very, very few machines at that time. I think Ford Motor Company was one of the only ones that had machines in the United States. And then, lo and behold, an America Make project came about where they plugged us in with Jerry Thiel. And they said, hey, hop in it. He said, yeah, come on out anytime. So I hopped in my truck and I drove, 10 hours or 700 miles door to door, and, got to meet Jerry. I hadn't really met him. But it was he was very receptive, opened up, open arms, welcomed us in and said, hey, we want to learn about this technology together. We want to push it out to the industry. And, so we were very, very excited, and, spent a lot of time out at University of Northern Iowa. They were very gracious, gave me some office space, and would drive 50,000 miles a year. Rich Leonardo would hop in the truck with me as the principal investigator of the America Makes project, keeping us online and helping make sure that we were to accomplish the mission at hand. We did a really good job of that with a lot of partners. It wasn't just us three, but this was kind of the core group. So, Jerry, if you can get your camera and your mic on, we're going to wait for you, and then I'm going to share the screen here, and we're going to hop into the presentation. But thanks so much, guys, for joining me this morning. And without further ado, I'm going to share my screen, and Jerry, you can hop right in on the presentation. All right, can everybody see the screen?
I can hear.
All right, sounds good, Jerry. Take it away.
Well, next slide. Okay. Back to the first slide. You'll see on the left-hand side the Modern Castings top tank. That was actually runner-up at one of the Cast Expos for the casting of the year. And on the right side, you can see those cores being produced. We had, and Brandon was around when we first started producing these. This was early in 2014. We've been doing this. We bought our printer in 2013. We sent X1 a PO and had the printer shipped over on a 747. We had the printer on U.S. soil within 1 week, and installed on the 3rd floor of the building within a month. So, very interesting start to what we wanted to do. And next slide is advance the metal casting industry with this really fantastic new technology. A little bit about the Metal Casting Center, if you're not familiar with us. We've been in existence over 30 years. We're one of the longest operating centers of excellence for metal castings at a university in the world. We do product testing services for the foundry's material supply chain, applied research and technology for the foundry industry, program support for the university's academic program. In fact, over the last 7 years, we've spent over $2 million on student salaries alone. These students have an opportunity to work up to 4 years part-time at the metal casting and additive manufacturing centers, and very highly recruited and sought after by the industry. They have those skill sets for a company to be able to adopt manufacturing 4.0 technologies. And that's our major benefit to the industry. And then also direct support to the operating foundry industry on solving some issues in the materials, processing of metal castings. Next slide. So what did we do? We took our experience in industrial research, foundry materials and processes. We knew how to stick sand together very, very well, and we applied it to additive manufacturing. We're very highly involved in the industry associations, the American Foundry Society, Steel Foundry Society of America, Non-Ferrous Foundry Society, and also the Investment Casting Institute. Demonstration projects are our specialty. We focus on OEMs, and this is important to understand. We focus on OEMs because they're the purchasing in the supply chain. For them to understand the potential of new technologies, once they understand and they start looking at parts being produced, Then we moved down to the small to medium size supply chain for castings to be able to provide information and support to adopt and utilize. Defense projects, we have defense projects with the Army, the Navy, the Air Force, and through the Defense Logistic Agency and national labs. Next slide. So we were the first university to purchase a large industrial sand printer. And everyone asked me, why did you buy this thing? And the answer was pretty short. If a company takes a risk to buy a piece of equipment that's $1.5 million and it fails, then it's a big deal. We can fail. We can make those mistakes up front. Also, with developing materials, low cost and regionally available materials for the industry. So let the universities take the risk and the research and development. Let the industry take the advantages and the benefits from that research. We've developed over a dozen aggregates for 3D sand printing. We were told that this is impossible. You can't do this. We need special sand. We showed the industry, we showed the OEMs that using different setups and using care, that just about any commercial molding aggregate can be used for 3D sand printing. And the university still prints more materials than really any sand printer in the world, including X1. We developed domestic furan resins and various catalysts and formulations. We developed the first iron oxide feeder for steel castings or heavy iron castings to prevent veining and in cores produced by a 3D sand printer. And we're currently helping equipment suppliers develop the next generation sand printer. For those of you who are fairly new to the sand printing industry, the work we did at UNI reduced the cost of printing materials, that's resins and sands, over 80% from the original materials offered by the printing companies. Next slide. So we talk about helping companies, one, develop the products for 3D sand printing, or develop the technology. What you see here is what we call the alpha printer. We'll talk a little bit about the beta printer, which is a little bigger one. This one is a printer used for research and development of those resin systems. Furan, phenolics, inorganic binders, and more recently, urethane type binders for additive manufacturing, which have much more compatibility than the furan resins that are the majority use today. Industrial research, development of multiple domestic 3D printing aggregates. We look at working with new companies, both in the natural mineral deposits, whether that is silica, whether that is chromite or zircon, or the man-made aggregates such as the ceramics, the mullites, and also our industry associations, our staffs. And how do we get this information out to people? Our staff serves on over 8 technical committees through the technical organizations. So we are out in foundries, talking to people, transferring this knowledge. Next slide. Also, I'll put a little plug in for investment casting. As a lot of research and development centers for the foundry industry, we're working into manufacturing 4.0. And we're looking at fully operated, fully automated units that take the requirement of the manual labor out of the production process. And this does 2 things. It has a great effect to control costs of producing products, but it also removes the human error. So we can do things the same way every time. Low-cost sensors, you'll see us publishing information on sensors that give us temperature, moisture, gas chemistry, pressure, shift, or impact. We can either install these sensors for Internet of Things information on equipment or place these inside of molds or cores to give us the exact conditions so we can make better decisions. All of this Internet of Things and sensors is to provide information to the foundryman to make those good decisions, but also to understand what's happening now, not in a week or so when the castings end up in the clean room. Robotics and automation in casting finishing, and also next-gen sand printing. Next slide. So what I want to talk about is what's happening now in research and development in 3D sand printing. And I'll go to domestic quality. So domestic quality for a North American OEM, and in this case, it's Tinker Omega, Springfield, Illinois. This is our beta printer. It's been a long time coming. I get ribbed by a lot of people in the industry. Hey, you got that printer yet? It is a long time coming because the technology advancements that will be made in this equipment are substantial. Increased speed, and we're talking about printing molds and cores the day you need them. Not for tomorrow, not for the day after. More choices, and the system won't be tied to a specific resin system. So it'd be available to run these new systems that we're working on right now. Greater flexibility to vary resin percentages within the same job box to give you a selection of core strengths, one for easy shakeout and one for small, lacy, delicate cores. And also the next generation of software with increased capabilities. All this takes time. We're hoping to receive the printer within the next 30 days. Next slide. So moving into what are we working on again? Manufacturing 4.0 technologies, which have been proven to really advance the foundry industry and suppliers of castings. If there's one thing, and we talked about this before the presentation started, it's the companies that are spending capital and making capital improvements in automation and technology that are viable for the future. The castings that have refused to adopt or did not have the capital to modernize and automate their companies are really sadly falling behind and closing at a very disturbing rate. We call these manufacturing 4.0 technologies, and additive manufacturing is a big part of that. Not just in sand printing, but also in printing tooling, printing patterns for investment casting. Additive manufacturing is making the time between design conception and realization of that casting incredibly short, where we can have complicated castings within 24 hours. Automation, removing the manual labor, advanced manufacturing processes, process sensors, and the Internet of Things. We're pushing the limits of current technology in sand printing, also to reduce respirable silica, and also to utilize sands that we would have never used in the past. Cost, availability, and time to market. Also, one of the things we're working on is stronger heat-resistant cores. If you've used phenolic, either phenolic or furanic cores, you know that there's limitations in the size of that core, in the laciness, and the ability to be able to pour higher temperature alloys such as steel for dies, or even those pencil cores for light metals, aerospace castings. We are working on technology that improves the strength of those printed cores by 4 times. And usually we're looking at about 250 to 300 transverse strength on a printed sand core. and we've run cores over 1,000 PSI. That, coincidentally, also shake out very easily when cast. Next slide, please. So what are we developing technologies for? Hybrid molding, better performance in resin systems, better surface finish through coatings, faster and more flexible printers, better software, process sensors, and increased use of non-silica sands. In this, I wanted to throw this in the end because everybody thinks that all this is very, very simple and easy. Down in the left-hand corner, you'll see cores for these were some of the first printed cores for aerospace castings. This was for a prototype engine, not flight ready, but on the test stand for SpaceX, their rocket engines. And on the bottom right, you see the result of some of our testing and some of our pushing the technology as far as it will go. And I'll conclude after that.
Thanks, Jerry. We're going to run right into Rich and his DoD perspective, and then we'll open up for a Q&A at the end. Thank you so much.
Thanks, Jerry and Brandon, for the intros, and Jerry for all what you and I has done with workforce development and Tech D. Greatly appreciate it. My pitch today for the audience is to stimulate conversation at the tables about how we sell the advancement in terms of utilization of additive manufacturing for tooling to the ultimate customers who benefit from what all of you do. And so I hope to pull that thread out and give you my limited perspective. And of course, I'm just a consultant, so I'm not speaking officially for DoD, but this is the things that I've seen lately. So I have 3 slides. We'll get through them real quick, and hopefully there will be a lot of chat. Brandon, next slide, please. So I guess I wanted to approach this from a simple SWOT analysis and pick all of your brains on how we communicate our value proposition for tooling. And I need to learn from all of you because every day I learn more from folks like Jerry and Brandon and Kirk and Cynthia and all of you who are actually out there making things happen. And it's interesting that Ford Motor Company, and maybe we have the guy who made it all happen at Ford on today, and who responded to an invitation on LinkedIn for me and helped guide me on how to do an America Makes project. Or maybe we have somebody out of Keyport who also had an S15, in the 90s and had the early arrival of X1 technologies to do in-house stuff for DoD. Now we have Rock Island Army Arsenal with an X1 asset. We have Tinker Air Force Base and the React team with X1 asset. And so the organic capabilities in DoD means that the DoD enterprise, including the R&D organizations, know the opportunities that binder jetting can provide in terms of schedule and also complexity and moving towards production of parts and addressing what we all know. Castings and forgings are always long lead time in the eyes of DoD, right? Significant investment that I see, I'm consulting on a project for the Air Force under AFWorks, and they're going really fast using pitch decks by which small companies like mine can go to a university powerhouse like Jerry and say, hey, Jerry, I want to do a small business innovative research or small business technology transfer around a widget and the technology, and I want to use AM. And DoD is funding a lot of research around additive, but also, as Jerry mentioned, around advanced manufacturing, which involves robotics and sensors and IoT. And as we all know, and those of you who are out there doing global work, Europe and Asia are making a lot of investment from their governments as well. So that's the opportunity before us. There's investments going on, awareness of the tech investments and areas that impact us. I think the challenge, and this is where I need to hear from you guys at the chat table, is how the heck do you explain tooling to your grandma, your spouse, or an ultimate client who says, what do you do? And you say, oh, we use additive manufacturing, we're a foundry, or we're using high-speed technology so that we get a part to you faster. And I think that's the challenge I need to learn from you guys. How do we communicate the value proposition of what great universities like University of Northern Iowa is doing, or Hometown Products, who makes the investment in this, when ultimately the customer or whoever uses that part may not get to see the speed, the market advantage. And I'll use, if I'm a commander, warfighting sync, and I have to put platforms against the task, you know, is that plane, tank, ship, or underwater platform more available to me because of all of you guys here at this presentation today? And if it isn't, not because of your fault, but because of the bureaucratic defense procurement process, I don't see the value proposition that you give me. And I think that's what I need to learn from you guys, is how do we communicate the value of AM for tooling out there, when all I hear from 4-stars is, we want to be the first service that uses a printed part on an aircraft, right? And then I try to change that conversation into, how about you increase operation availability of that aircraft, or the cost for maintenance repair operations because of additive manufacturing? So we try to change the dialogue, but again, I need to learn from you guys on how tooling and its benefits are advantages to the ultimate end user. Let's say 5 years from now, our kids are driving cars that are hybrid electric, or we are, maybe a Lordstown Motors pickup truck, and the body panels are lighter because of the benefits of additive manufacturing for tooling. And how do we put ourselves in that success chain? Next slide, please. So those are some initial observations that I wanted to throw out to you. And on the next slide that Brandon will put up here, we'll talk about a couple other things. So I'm changing SWOT from opportunities and threats in terms of order. The big thing I notice is there's more and more investment and discussion on direct printing of parts. And all of the DoD forums and the National Defense Industrial Association Manufacturing Division meetings, more and more investment goes from tooling to say, we want to directly print the part, because that's the way we skip process steps, we save time, and we save money. And I don't necessarily agree with that logic, but that's what happened. Last week or the week before, I saw 2 briefs on direct and energy deposition technology funding from DoD to small businesses for casting repair. So it's this old thing, casting versus weldments discussion, right? And we all know, and we all hope, that AM technologies like DED continue to advance, but what does it mean to all of us in the room, right? Is it a threat like I throw out here? I don't know, but I think it's a discussion point, and I think it leads us to opportunities. The other threat I would tell you guys is, and I don't want to mean it as a threat, but it's a challenge in terms of supply chain retention and supply chain recruitment. From my perspective, as a consultant, I try to play around a little bit to be a DLA vendor, or throw in R&D projects for my own company as well as others. And there's more and more scrutiny about how we handle the digital thread. How are we handling all the way to you, whether you're an engineering service, whether you're a foundry, whether you're a pattern shop, a print shop, a university, a fellow company, a machine shop. How are we securing the technical data package? And we could all argue about DoD and DLA needs to do more about 2D to 3D file conversion, right? Roger, got that. But ultimately what they're putting on us as supply chain members is, you have to handle the digital thread securely. And oh, by the way, here's a new requirement. And every week there's a new requirement. It looks simple. And then when you go to find it, you got to go to 3 federal websites and register for this and have a password book that's thicker than the old phone book. So those are some of the challenges. The opportunities here, though, is that we, because of all of you, have gotten our names out here in multiple industries, whether it's the standardization industries, the other transactional authorities, such as America Makes and other organizations, AMC, and we're showing how to get standardized efforts in terms of tech integration, reduce process variability because of the great work folks like Jerry's doing. And we have the opportunity, each of us, to educate our clients, and ultimately folks like me try to inform DoD leaders about the value proposition, right? There's all the Beltway folks who are really sharp on how to get us money, but when we get out there, we have to inform them of the tactical successes on how things like binder jetting makes a platform more available against the task, even though they don't know about the value proposition, how it's going through tier 2s, tier 1s, to an OEM who sells it to DoD, and so forth. And so I would say, and get yourself involved. A simple example is the AFS training, I think, is the largest of it, but also have cognizance of these other venues. And if you would like to brief at these venues, let me know, and I'll ping folks like Stephanie Gaffney at YBI or Marilyn Gasca or folks up at OSD, so you can get what you're doing with this technology out to a broader audience, especially those who invest in DoD, and those investments go beyond DoD out to the commercial sector, and hopefully parallel the investments that the OEMs would like to see out of our supply chain, so we can work globally. Ending with that, you know, regional manufacturing ecosystems are what we need here to support the defense community in a peer-to-near-peer operation. And so if you're doing this globally already, come on down, help create another regional ecosystem throughout the United States that also allows you to compete globally. And maybe we could chat about that as well, and how this technology, along with other technologies that are enabling automation, robotics, and other additive, can all work together to bring our industry up. And how do we effectively communicate our value proposition? So I'm excited and honored to chat here today, but I'm mostly excited about learning from all of you on how we skin this cat, so to speak, and better communicate the value proposition all you bring to the plate. Honored, happy St. Patty's Day from a guy who's all Italian. I'm wearing green and trying to play nicely. Thank you, and Brandon and Jerry, back over to you guys.
All right, thanks, Rich. You know, everybody here may have heard or maybe, you know, worked with Hometown in the past, but, you know, it was kind of a tall task, you know, for a small company like ours to you know, to see the need. You know, you start all the way up, you know, in the DoD supply chain. You know, we need a casting to get this plane off the ground. It seems simple, but you see what it took for all of us to get this going. You know, we had to reach out through this, you know, this DoD started additive manufacturing center right in Youngstown, Ohio. And then we had to work, you know, with Jerry Thiel, you know, out at UNI with the first printer that a university had in order to get where Hometown is today. So, you know, I brought, you know, like I said earlier, like I said, this is like getting the band back together. You know, I worked closely with these guys for so many years, and I just wanted to kind of get everybody back together. So, because there's a lot of foundries that are in that place right now. You know, where do we make advancements? Where do we take, and where do we, you know, put investments? And, you know, it takes, you know, you have to take that first step and jump out and say, okay, maybe we need to come alongside someone. And a lot of people have come alongside of Hometown. We have a lot of great, you know, customers and clients, and we do consulting, but you know, we're helping our customers crawl, walk, run, you know, where they might print some parts on our printers. And then next thing you know, we're helping them install a printer. Next week, I'll be at one of our clients, you know, installing, you know, an S-Max 3D sand printer and giving training on, you know, how to best utilize that technology in their foundry. And you know, we're honored to do that. And, you know, having the team and the support, you know, with Rich and everything, you know, that's how we're going to get into production. That's how we're going to get into, you know, cores and molds, you know, 30, 40, 50,000 pieces a year. You know, I mean, maybe more, you know, as Jerry continues to work on the latest and greatest printers and technology. But, you know, that's where we're really going, you know, as a company. You know, we were honored, you know, to become one of the National Association Manufacturers of the Year, you know, in an industry that's been so, you know, so set for so long. You know, I mean, it goes back to, you know, thousands of years of, you know, pouring metal into sand, but to innovate. And, you know, like I said, it's the team and it's all the people, it's our clients, our customers that work with us to get us to that point. So I just wanted to touch, you know, base back with the team. You thank you everyone for joining, and listening here today. Now we're going to open up for some Q&A so we can really deep dive into, what we're doing, as a group collectively to keep advancing this industry. We're not done yet. We're just getting started. So, Jerry, if you guys want to turn your mics and cameras back on, Rich, see over. I'm going to pop over to the Q&A, see what kind of questions we have here. Yeah, thanks again, guys. Rich, turn your mic on. We got it ready. All right, great. All right. So one of the first questions we have here is curious on the Tinker Omega printer. Is there any kind of cut sheet for it, or is it too new to have documentation? So Jerry, I'll let you field that one.
I think if you go to the Tinker Omega website, it may be there, but it is too new. So it is too new.
Especially speeds and all that. I mean, you're still kind of developing some of that. I mean, it might have a close estimate, but you're still developing the finals. Is that fair to say?
Well, we started off this project looking at a 10-time improvement in printing speed. So if we look at even the 28-second per layer time, we're looking at something substantially less.
Sounds good.
The technology is going to allow us to go.
Yeah, there's a lot of interest in that, obviously. I mean, the cost of printed molds and cores, started out, much higher than conventionally made cores and molds. So obviously, all the work that you've done to drive down the cost of the consumables, has really helped. But we also have to keep working on speed, getting them faster, and then also getting the price point of those down. So, all right, another question here. I had a couple votes on it. Cosel in China has developed large high-speed printer. How does that compare with technology being developed in the U.S. and Europe? So I'm going to start off on that one. I was actually invited. I went to GIFA and had made some relationships, and I was actually planning on traveling to China. There was actually two printers. Jerry and I had both at GIFA had reviewed the AmSky printer, and then was also invited to Cosel, not only for the fact that they had purchased, I think they purchased two X1X serials, and then more recently had magically developed their own printers, I think, that look very similar. And I think they were also printing, I believe, if not 100%, primarily they were printing with a ceramic media that was being manufactured in China. So that to me, what I saw, I wasn't able to travel there yet due to COVID. But what I saw was that the machines that they supposedly developed were actually very similar to the X1X serial that they had purchased. So I would say that technology was probably closer to being copied rather than developed. So I would say that was probably German technology.
Yeah,
Jerry, what's your perception on that?
Well, I don't think there was any doubt that that those were very similar to the exterior units. They made them run when others could not, but that's still older technology. It's still the first generation sand printers. I think we saw from the S15 up to the S-Max, we saw faster speeds, but still with that rastering technology and the recoding technology that really limited and does limit the speed right now. So newer technology, different mechanisms, different ways of doing that are going to increase that speed and bring the cost down. So brings cost down through simplicity.
Absolutely. So, Rich, I had seen something, I don't have all the details, but I just saw an announcement by X1 that they were going to put a 3D printer in a container ship. Have you read anything on that article yet?
No, Brandon, I have not.
So I found the article interesting because, I mean, I believe, from a DoD perspective, it would actually get manufacturing closer to the point of need. I don't know if, I don't think that it would be binder jetting and actually have a foundry to cast a part, in a forward, theater environment. But what's your perspective? I mean, of having, 3D printed parts at point of need, from a DoD perspective, is that the ultimate goal?
I think our concept of sustainment hasn't changed much. The closer we can get to point of need, the better. If you look at the way the Navy has done things, a lot of you've known about forward casting experts and capabilities, whether it be in Pearl Harbor or in Subic Bay in the Pacific for the PACOM fight. And the ability to manufacture forward is, we have machine trades who use CNC welders and containers on the battle space. And years ago, I'm sure a bunch of you saw the Made in Space folks who put a 3D printer up in space. And then we had a YBI portfolio company here, AST2, who had printers going on Navy ships because the Navy ship has more capability for manufacture, right? And they had to deal with the yaw and turn and what's experienced on a ship. So I think it makes sense. We've seen special operational forces, and we've been part of projects where we've helped to containerize additive manufacturing capabilities. And here's a little whiz bang for all of you. When I left the military academy in '99 to my first real acquisition job, I had to write a requirements document for the training and doctrine command based on a congressional coming out of Michigan for the mobile parts hospital. And the mobile parts hospital concept was something that was in a container forward as DoD moved, a forward-based, here's moving mountains, like when I was in general aid for Schwarzkopf, to just-in-time logistics similar to where industry is. And that mobile parts hospital came to the battlefield in '03 when I was running around trying to do armor. But how we fit it into the concept of logistics, that new technology, had not been worked out yet. So these technology demonstrators, Brandon, are great. And then we have to figure out how does it work in from a concept of sustainment so we could do it. But it's definitely something to follow in terms of the ability to make parts forward as appropriate. So what do we all want? Increased platform availability, increased response time from the supply chain. And that involves a lot of things, like Jerry pointed out, Brandon. We're all moving to that digital thread, right? Where somebody's going to send you a file.
Yep.
If Jerry said something about that printer, I can print you something for that day. Can we finish it that day? And when does somebody have it in their hands? And where do they live, right? And that's a great discussion.
Well, that's exactly right. I mean, I think By Castings, company in Ohio, years ago was contracted either by the AFS or the Army, to basically put a foundry in a couple of containers, But at the end of the day, if you don't have all the machining capability and everything else, would you be better off to just have very rapid, centers, like you said, positioned to where you send them the technical data package, they can run simulation, they can design it, they can print it, cast it, and then do all the machining operations. Because just because you have a foundry, out, in a forward location doesn't mean you can do all the post processing. A lot of aluminum parts now are needing hipping and all these other processes that the foundry is one thing, but actually getting that that part or that component ready to bolt onto a tank or a truck or a plane, that's a whole different story. So,
well, I'll bring this up. And we worked on 2 projects with Army Research Labs, and understand research, especially for the military, is looking at technologies that we probably can't do right now. By the way, the Army had containers with portable foundries for years. They had 2 large containers with conventional continuous mixers, molding stations, and a small induction furnace to be able to pour parts at point of use. That was disassembled a couple of years ago. they're thinking about putting 3D sand printing, binder jetting in a container for a much more reduced space requirement container. But I think the current endeavors right now, the current publicity you're seeing on X1, I believe is all direct metal.
Right.
They've made some great advancements along with Oak Ridge National Labs and some of the binders, and they're doing expanding their ability to print 3D or binder jet print metal powders. So.
Yep. Very good. Another question we have on here is probably more for Jerry. What is the status of inorganic binder system in the USA? So when we went over to GIFA, a lot of the focus, over in Europe was obviously inorganic. And I know, Jerry, you've dabbled a little bit in that space. So do you have a perception? I mean, now I do know, I think there is a presentation tomorrow. AFS and X1, I think, are going to have an inorganic binder presentation. So I would definitely tell people, to look into that. But I don't know of any other printers in the US that are, I think everybody's doing it pretty much in Europe, but I don't know of any anyone else really pushing the technology. So what's your perspective on the status of the binder in the US? Are we manufacturing it here yet? Or is it all coming over from Germany and Europe? What are your thoughts, Jerry?
All the inorganic binders, I know that ASK is working on inorganic resins. I believe the current X1 technology is based on the Hoopness Albertus. That's all coming out of Germany. The HA International, I do not believe has been licensed yet to produce the materials. When you look at inorganic binders, I think it's the desirability and the need. Is
Right.
someone buying a printer based on IOBs? And the answer is probably no just yet. But we have Lempe that is using IOBs over in Germany. We also have VoxelJet with their production system is using IOBs in Germany. So yes, the technology has been available. It's a little more complicated with the drying steps. As far as I'm aware, it's not a cold curing system. So there is more complexity to the system. One, I think the X1 is just waiting for people to buy the technology.
I agree. I've been approached several times. Hey, why don't you have a phenolic printer yet? Why don't you have a phenolic printer? And I was like, you know what my demand for 3D printed phenolic cores is? Like $5 a month. So why, as a print service provider, we may be one of the largest in the country, but if all the demand is for, most people want a low cost, or at least get close to conventional core making prices for cores and molds. If I only have one or two people approaching me a month saying, hey, can you try this little spindly pipe core? I'm like, I could print that one or two cores for you, but you're going to have to pay for, all the resin, all the binder, to set up and run for 2 cores. Jerry, you and I had this discussion all the time when, we first brought our first couple of jobs, to you and I for printing. I'm like, hey, I finally got a sale. And it's like, I sold it for X and it was going to cost you X times 5 to print that part because, we didn't have enough to fill up the job box at that point. So you're spreading all this material, you're spreading all this, activator on the sand, you're running this $1 million+ asset, to make, $20 in revenue. It just didn't make sense. So
There has been really successful islands of technology for the phenolic resins.
Oh, absolutely.
So I think Danko Arlington has been very successful with their metal operations.
I've heard great things out of VoxelJet, their service center, and like I said, I don't have anything against the technology. I think it just, circling back to the inorganic, what's the status? I would say the status is there's just a very low demand.
I think when we talk about strength, both room temperature strengths and high temperature strengths, we really didn't see the improvement that was promised with the phenolics. So although we see, say, double the transverse strength at 400 or 600 degrees C, we're going from 6 to 12 psi. It's still not enough. So I think some of the new technologies that we're working on, and we'll see in the next 6 to 8 months, are strengths, high temperature strengths that are not being able to see, that we can't see right now with any of the current technologies. Whether that's IOB or whether that's phenolic resin, those strengths are not high enough for thin cores and either high temperature alloys. So,
yep.
But I think that technology is very a short distance away.
Absolutely. Well, gentlemen, I don't know if you have anything else in closing. We've kind of ran through the questions here, so that means you guys all did a, let me see if there's any more. Oh, no, there is a couple more. Sorry, I had to page down. How do you vision what we may see at 2022 Metal Casting Congress relating to AM and Foundry 4.0 in Columbus to dramatically different than what we saw in Atlanta?
Oh, I think the technology is changing every 6 months. So the advancements that are being made, you know, I'm talking to companies that are adopting Internet of Things for increased information on their processes. We're looking at really advancements in molding and core techniques. I think we're going to see a lot of new things. So I'm really looking forward to next year when I can shake hands and meet face to face.
And if I might add to that, you guys remember very well, along with guys like Tom Truca and Jitin Shah and Harold Sears and others, at earlier AFS events, when we were talking about sand printing, we had guys like Jerry and Rick Lucas and a couple of OEMs talk about how they were using sand printing. And then as our presentations in AF events grew, you guys remember we had a standing room only forum once. And now what I hope is that instead of having nonprofits and consultants, we have Jerry and some of the OEMs going on our level, but we mostly have small and medium-sized manufacturers talking about and conversing about how they're using this technology to meet needs and to be globally competitive. And so, well, I think there should be a technology component at that forum in 2022. What I hope to see is that industry has caught up with the technology and we're dialoguing collectively. And before we go out and have some great steaks in Columbus that night and some cold beer, the forums during the day will be about small and medium manufacturers who are leveraging this technology for their benefit and the benefit for all. That's what I hope we see.
Very good. Yeah, I agree. One of the last questions here in the Q&A before we're going to push out to our tables, so everybody stick around. Come and visit myself, Jerry, or Rich. We'll be out there for probably 20 minutes, half hour. If people stick around. But thanks once again everybody for joining. The last question here was, what are the biggest challenges of sand 3D printing in terms of quality control, and how do you address them? I can speak to that briefly, and then I'll have Jerry weigh in. But some of the quality control, it's just really watching your inputs, make sure that you have good quality sand, the acid levels, and everything is monitored and pretty neutral. And then as well as your binder on these print heads, you're basically pumping a Furion binder for orifices that are size smaller than the human hair. So what we want to make sure is that we're getting a good quality, consumable from our customers, and then it's basically just making sure that the printers are operating in a very controlled environment. Humidity has a lot to affect. You're basically filling up a recoder full of damp sand, and you're trying to lay those layers very evenly. So if you get a big swing in humidity, the activator level can really wreak havoc on your printers. And like on the one slide Jerry had shown, it looked like the recoder may have plugged up, and the printer just kept printing binder, but the sand wasn't falling out. So you come into quite a mess on those mornings. But those are some of the biggest things, because the way that you're spreading the sand and pushing the sand. If you get pushing or streaking, those are a lot of the quality defects. I mean, the printers run really sound if you have good quality inputs and you keep it in a monitored environment. Jerry, your perspective, you've been on this longer than anyone, so what do you
90% of the quality of the materials we put in that printer.
Yep.
So the technology is very solid. We have our technology is one of the older units in the U.S. and consistently really requires minimal maintenance and downtime every year. So a big shout out to X1 for a very well engineered and manufactured piece of equipment. But
yeah,
that's not saying I'm not looking forward to new technology.
Right.
Faster, cheaper, better. So
yeah, absolutely. Well, gentlemen, can't express enough, how much you guys have done, to help, our company, myself, my personal development, in the industry. It's been great, working with you guys for all these years. Glad to see that you're all, successful and, continue to innovate, your businesses. Thank you so much for the time. I know this year has kind of started out pretty hectic, so I know it's hard for everybody to carve out an hour here and there when, all it's going to do is put an hour on the end of your day. So really appreciate, I think we had over 75, registrants. So, this will be, disseminated out to them and hopefully throughout their organization. So, I really appreciate you guys coming on and, and sharing your insights, from technology to, to opportunities, as Rich had mentioned, and challenges so that we can continue to innovate and continue to go to the next level. So we're going to push out to the tables. Everybody have a safe and happy St. Patty's Day. Thanks for spending, some time with us this morning. Hopefully you can stick around and ask any directed questions at the tables, and we'll see you next time. Take care.